Good afternoon. My name is Katie Kurgan, and I am the Senior Program Manager for Environment at AASHTO. Welcome to the webinar. Today's webinar, Post-Construction BMP Selection, Runoff Management to Meet Quantitative Pollution Limits, is sponsored by the Center for Environmental Excellence by AASHTO in cooperation with the Federal Highway Administration and Federal Transit Administration. Due to the number of participants in this and previous webinars, it is clear that stormwater is a topic of great interest. I would like to take a moment to say a few words about the Center and its products. The Center for Environmental Excellence has been developed by AASHTO in cooperation with the Federal Highway Administration. The Center's mission is to promote environmental stewardship and to encourage innovative ways to streamline the transportation delivery process. On our website, we offer a wealth of information for environmental and transportation practitioners. All of our webinars, including today's, are recorded. In June of 2011, we held a webinar entitled Efficient and Innovative Strategies for Achieving Better Environmental Performance. And in April of 2011, we held a webinar titled Construction Guidelines, Numeric Limits Are Coming. Both of these are available on the Center's website now. Today's webinar will be available in a few weeks for on-demand viewing. If you would like to be notified of future webinars, just sign up for our broadcast emails on our Center's website. Other stormwater products include our DOT Stormwater Community of Practice. The Community of Practice has two primary goals, the first of which is to extend each state DOT's network and contacts, enabling them to share experiences and engage in technology transfer, and the second is to develop a State of the Practice report. On this slide, you can see various topics that we have discussed previously and reports that are posted on the Center website. Currently, the Community of Practice is discussing program effectiveness assessment, including metrics used to define effectiveness, audits, results and lessons learned going through either EPA or your regulator, and DOT organization, interdisciplinary teams, and best generic structure for a DOT. Also available on our website is developing and implementing a stormwater management program in a transportation agency, practitioner's handbook and webinar. The purpose of this handbook is to assist transportation agencies in developing and or implementing a stormwater management program that satisfies the requirements of the Clean Water Act. For agencies that already have a functioning stormwater management program, the handbook provides useful tips and transportation-specific references to assist program implementation. As you can see, this handbook is also available on our website. Again, thank you for your participation today. I will now turn it over to Eric Strucker, our moderator for today's webinar, for additional opening remarks.
Thanks, Katie. Good morning, everybody, or good afternoon, depending on where you are, and welcome to today's webinar. My name is Eric Strecker, and I'm with Geosyntec Consultants in Portland, Oregon. And I wanted to acknowledge support from both Neil Weinstein for the Center for Low Impact Development and Marie Venner of Venner Consulting in organizing today's webinar. So today's webinar is Post-Construction BMP Selection and Runoff Management to Meet Quantitative Pollution Limits. It's intended to help you address the increasing challenges of stormwater-focused environmental regulations, and in particular meeting numerical pollutant limits or volume limits. DOTs have been facing increasingly stringent permit requirements, including numerical effluent quality limits, at the same time they face severe budget shortfalls. We'll explore the issues that are driving numerical requirements, the research and guidance information available to assist with BMP selection and design, and then how some of the DOTs are responding to the new stormwater regulatory requirements and demands, as well as learn about different requirements the DOTs are facing and innovative approaches and strategies for addressing these. So we're now going to do a short poll just so we can learn a little bit more about our audience, and we'll actually take a look at the 3 questions that are up here. So I'm going to put this poll up, and if you could be ready to answer those, that would be great. So the first question ought to show up here in a minute. So I'll give you a minute here to answer the question. Looks like about 60% of you have voted. I'll probably cut it off at about 80 or 90% or so. All right, 85%. That's probably a pretty good number. So share, there we go. So yeah, as you can see from the slide, we have about almost 45% of you that are engineering and design, 11% in construction management oversight, 26% environmental, 13% hydrology and hydraulics, and about 6% of you that are operations and management focus. So now I'm going to put up another poll question here. Let's see here. Oh, I think I managed to put the same poll question up. We'll give it one more shot here. All right, so now we're going to ask a question about how many of you are at the location that you're at. All right, that's pretty good participation there. So sharing these results with you, most of you, above 75%, just one of you, and then you can see the rest of the percentages there. So again, I thank you for answering that question. Kind of helps us figure out how many people are actually participating in the webinar today. And I think with that, I'm going to move on to the rest of the presentation for today. So today's speakers include Scott McGowan, myself, Lee Nguyen, Michael Barrett, and Peter Matajet. Scott is the Chief Environmental Engineer for the California Department of Transportation, and he'll present on drivers for post-construction BMP selection and design. I will then present BMP selection and design steps and some NCHRP research manual and guidance that could be helpful. Lee is a hydraulics engineer with the Washington State Department of Transportation. He'll be presenting on his DOT's approach to meeting specific pollutant requirements. Mike is a research associate professor with the University of Texas. He'll present on porous pavement overlays and their potential for addressing highway pollutants. And Peter is the MPDS coordinator with the Maryland Transportation Authority, and he'll wrap up our presentation today with asset management and keeping track of BMPs to ensure their effectiveness. So each speaker today is going to have approximately 10 to 20 minutes for their presentations, and then the presentations will be followed by a question and answer period at the end. And you can submit questions at any time via the GoToWebinar sidebar that you should have on your screen. So I invite you to do that, because actually getting the questions ahead of time helps me as the moderator look ahead and get ready to ask the panelists those questions. We had 240 sites that registered for this webinar today. There's actually 172 of those active right now. So again, there's a lot of interest with that. So with that, I'm going to hand over the presentation to Scott, so he can give his talk.
Thank you, Eric. During this first presentation, I'm going to focus on the drivers for post-construction BMPs specific to transportation agencies. Again, I'm Scott McGowan, the Chief Environmental Engineer at Caltrans, and I'm responsible for the statewide stormwater program, which includes the management, development, implementation of stormwater elements from project planning to construction and operation and maintenance. Some of the regulatory drivers. taking a while to switch here. Not sure, Eric, if I got control. I can't move it. There we go. Some of the regulatory drivers are the Clean Water Act, some of the drivers that require DOTS to implement post-construction BMPs is primarily due to compliance with the Clean Water Act, National Pollutant Discharge Elimination System, or our NPDES permits. Post-construction BMPs are incorporated as part of our projects and as part of our new construction, project reconstruction, and through our retrofit projects. We also are required to comply with total maximum daily loads, which are mandates for fixed impairment of a water body. TMDLs require us to retrofit post-construction BMPs to meet waste load allocations assigned to each Department of Transportation. Post-construction BMPs could also be triggered to comply with protection of wetlands. Another driver is complying with the Endangered Species Act, which may impose meeting stringent water quality requirements, triggering implementation of post-construction BMPs. Some of the other emerging stormwater issues that we're seeing is the National Academies of Science. The regulatory requirements for stormwater keep getting stringent. This report shown here recognized that current stormwater program was not sufficient to protect the beneficial uses of the receiving waters. The report recommends that stormwater regulations need to emphasize on volume control. Addition of impervious areas due to highway improvements can increase runoff volume, which may result in changes to downstream natural channels. The report also recommended watershed-based permitting. Currently, many permits are focused on just jurisdictional boundaries. The report also recommends for EPA to impose rules to ban sources at the national level. An example is elimination of copper and brake pads. Caltrans has been engaged in partnerships working on elimination of use of copper and brake pads. Controlling copper at the sources if source control would be beneficial rather than construction of costly BMPs. And the EPA stormwater rulemaking has been underway for several years now. It's currently delayed, but a rule is likely expected to be released sometime in the next few months or within a year. Some continuing emerging issues in stormwater. I'm sorry. Apologize, I'm having a problem here.
So Scott, we're seeing the second emerging stormwater issues slide.
Yeah, I'm having a problem here. I need to go to the next slide.
The next slide? On integrated system?
No, go ahead and leave it at that one. I'm sorry.
Okay. So I'm going to go ahead and just advance your slides for you.
Okay, thank you.
Not working.
It's not working from my end.
Right.
I just wanted to continue and talk about the NPDES permits are also including requirements to comply with numeric effluent limitations, or NELs, as well as benchmarks in our construction general permit, the industrial permits, as well as the MS4 NPDES permits. NELs and benchmarks require us to meet a specific number. There are also requirements to retain runoff volume on the site to meet volume control requirements. There is also an EPA memo specifying how TMDLs are to be included in our permits. Since TMDLs is a mandate of meeting specific waste load, the emphasis has been meeting effluent limits, volume, and impervious area controls. Okay, next slide. This gives you an idea of what DOTS face with an integrated system of roads. It's similar to the rest of the nation here in California. You'll typically see a network of freeways, expressways, and conventional highways and toll roads, and we have to deal with this in dealing with stormwater of what kind of access control we have and where and how that affects our design, construction, and maintenance. We have a quote in our stormwater management plan that states that there is a need to have a consistent, effective, and efficient implementation of the stormwater management practices statewide in all of the Department of Transportation's statewide areas. We expect that stormwater program be consistent throughout all of the state in our DOTs. Consistency through applying the same principles, using the same forms, training, guidance documents, consistent implementation, and enforcement. This is key. Next slide. Our system condition for departments of transportation. You see from this picture, nothing's really changed except the cars. Our system was built in an environment where it was built decades ago before the water quality treatment standards were established for NPDES, and now we need to try to adjust our design, construction, and maintenance practices to meet that. We've always in the past tried to get water away from the structural section as fast as we can and as far away as we can in order to preserve the integrity of the pavement, safety purposes, and hydraulic purposes. And now we're being asked to slow the water down, treat it, and then release. We have unique operational conditions for a DOT. We're unique. We're not like a typical MS4. As we think about our designing, our construction, and operating and maintaining post-construction BMPs, we need to think of all of this because we're unique in the following reasons. We're linear, we're a thin strip, small piece of the watershed, we have limited right-of-way, we're frequently constrained by adjacent land uses, we have to be concerned with high speeds, high traffic speeds, our transportation corridor is highly controlled environment, we have a distance away from the travelway we refer to as clear recovery zone, which BMPs need to be designed for and considered. We have a right-of-way access control on freeways. Fencing and other barriers. We're a 24/7, 365 operation. Our highways need to facilitate emergency responses, and we also have seasonal operational activities. A lot of things to consider as a unique MS4. A huge challenge for us here in California and also for the rest of the nation are TMDLs. As you see in these maps, about 2/3 of the state of California drain to impaired water bodies, and the installation of post-construction BMPs is one of the ways to meet TMDL requirements, but we have challenges. We are a minor fraction of stakeholder. We're typically less than 2 to 5% of a watershed and a DOT. Our BMPs typically have catchments or draining areas serving 3 to 5 acreage. Our highways are adjacent to many jurisdictions. We have been named in multiple TMDLs, and in many cases, serial TMDLs are developed by our regulators for specific pollutants. And that gets back to not being able to look ahead for your design and construction considerations. We're assigned to wastewater allocations, and the schedules that were given for TMDLs do not necessarily align with project delivery, which could be problematic for a DOT in meeting TMDL mandated schedules. We have a detailed guidance that we follow for project delivery from planning through project completion. And I know that each DOT is very, very similar, that incorporating post-construction BMPs into project delivery also needs to meet this process. And we have a very detailed process where we have to follow and go through these different phases of project development. Some of the challenges for DOTs for maintenance and operations. Number one, safety. Our highest importance to a DOT is the safety of our personnel and of the traveling public and our contractors. And BMPs need to be constructed considering safety and providing safe access for maintenance and operations. Specifically, we do not allow drain inlet inserts or controls. Disruption of the flow of traffic needs to be considered. And lane closures to accommodate BMP access may not be acceptable. Sweeping is also a challenge since this affects the flow of traffic. In general, for many DOTs, operation and maintenance of BMPs is a challenge working in a limited right-of-way. For several years now, DOTs have been working together and collaborating with EPA as the national rulemaking develops and new regulations are developed. that the uniqueness of transportation agencies are considered. We had a vision of possibly recognizing a TS4, Transportation Separate Storm Sewer System, versus the MS4 typical of municipal programs, since we're so different. And there's a lot of reasons for this that we've been communicating with them on. We're funded differently, our colors of money, and what we can spend money on for types of stormwater controls. We have limited legal authority on enforcement of the uses of our facility, the users of our facility. Safety, again, is our #1 priority. We request revisiting the applicability of the 6 minimum measures typical of MS4 program. TMDL compliance is an issue for us since we cross virtually all watersheds with our complex roadway network that I had mentioned earlier. And we cannot address all water quality needs, so we need to prioritize our activities and our resources spent. And with all that work with EPA, they've actually created a specific website since they have recognized that DOTs are unique. And they actually have information posted specific to stormwater programs for DOTs, including materials, studies, applicable programs and permits, and other useful information. The website is noted at the top of this slide. I think this is an important step that EA has recognized, although it's still called MS4, which it should. It says road-related MS4. So working with some of these challenges and these drivers, what would be an ideal TS4? Well, we think that if we could focus on transportation pollutants, because we are a single land use, and the things that we know that we can work the hardest at eliminating. Pollution prevention, focus on source control. This can provide a bigger water quality benefit compared to costly structures, cost a lot to build and maintain. Treatment BMPs appropriate for highways. Not all BMPs applicable to typical MS4s are applicable for a highway environment. Allow pollutant trading. Other highway segments or off DOT property may be needed, especially in urban areas. The construction for highway, allowing segmenting risk levels, meaning our projects could be many miles and only a short segment may be at risk to a receiving water. Our ICID elimination on enforcement, work with the local MS4s, maybe issues with run-on flows, public education, one national message, and statewide a TMDL strategy. Level of effort is needed. This helps us from spreading our money around. And that's it for me.
All right. Thank you, Scott. And I liked your large particle there. Although I think the treatment for that's a little easier than some of the things like dissolved metals. So I'm going to give a little overview on post-construction BMP selection and some of the guidance that's out there to help folks with that. So as Scott very well described, there's lots of emerging issues that are driving numerical limits, things like TMDL's Endangered Species Act. I'll just add from my perspective also, and seeing what's happening with the Theophos waterway and the Willamette River down Portland, Theophos up in Puget Sound, that the CERCLA or the Superfund type cleanup programs also results in numerical limits that get applied to transportation agencies. So again, what's the guidance out there to help us all make better decisions? So I'll provide a summary of some of the NCHRP reports and those studies to you. So a couple of the key reports that are out there, there was report 440, and these are all available on NCHRP's website. And that looked at the impact of construction repair materials, so actually what the highways were built at and the potential impacts of those on surface and groundwaters. There's a report 521 out that gives an identification of research needs for highway runoff management. It was based upon some surveys or extensive surveys with the DOTs, as well as a review of the literature. There was a kind of a combined effort between the NCHRP and the Water Environment Research Foundation, and NCHRP stands for the National Cooperative Highway Research Program, if I failed to mention that. And basically both of these efforts were to take more of a look at unit processes, and then they were quickly followed up by the unit processes in terms of helping to select and design BMPs, and that was followed up by an effort looking at decentralized BMPs on behalf of WRF. So all of these documents could be useful for one. So just to highlight some of the stuff from these guidance that I think would be useful is, first of all, I mentioned the materials, construction materials, and this is a study that was conducted by Oregon State, lasted about 7 years, where they really looked at both the materials, they ground up a lot of things, and then looked at what kind of leachate they got from them, and then did testing in the laboratory on how that would interact with the other construction materials as well as the downstream soils and vegetation, and then developed models around that. And there's a lot of good guidance in there on that. So just an example is there's been an effort to, figure out what to do with all the scrap tires that we have, and some DOTs have incorporated some of these recycled materials in highway construction. And as we know, in tires, there's a lot of zinc, for example, and so is that a potential issue in terms of use of recycled tires? So the questions that they ask is, what possible impacts will occur to aquatic resources if those kinds of materials are used in construction or repair? And is there a risk of a problem? And then how should any environmental impacts be assessed? And their general conclusions were and results is, first, they developed an assessment methodology, which I think is applicable and usable. That's a modeling framework that one could look at and use. And some of the other findings were that, yes, the leachate from a number of the pure construction materials were often toxic to algae and Daphne in the toxicity testing they did. They found algae was the most sensitive. However, that toxicity was greatly reduced when it was incorporated into asphalt, concrete, or Portland cement. So again, there's an interaction between different construction materials that could tend to counteract the toxicity that you might see from the pure material. And then also the toxicity was significantly reduced in earthen and vegetated channels. So I mentioned the 2 documents on taking a unit processes-based approach, so I'll just provide a little bit of a summary from those. So again, the goals of these efforts were to really take the best information available, the combination of what we've been able to observe in BMP performance from things like the International BMP database, and then combine that with our knowledge of unit processes to really start thinking through, what are the pollutants of concern, what form do they come in, how do they arrive, and then given all that, what are the set of processes that we should have within our BMP? So getting away from, any BMP will do, or more of the black box approach. So again, we emphasized, the treatability, the fundamental unit processes. We then developed criteria of how practical things are. Certainly that's a consideration. And then there's both of those efforts resulted in guidance documents that one could use. And so what do I mean by unit processes? Well, what are the the hydrologic and hydraulic characteristics of the BMPs themselves? What treatment do they provide physically? So things like settling, and then also looking at the biological and or chemical treatment processes of BMPs. So an example, if you had a TMDL that said for trash and debris, fine particulates, total suspended solids, TSS, dissolved copper in volume or flow, instead of one BMP, you might actually have a series of BMPs, or it could be a BMP that all of these unit processes are built into. So in this case, one could have some trash racks going to a sedimentation forebay that's all a part of an extended detention system, flow control outlet to meter the flows out to meet the volume and energy downstream, for example, if you had a hydromod or erosion problem, and then perhaps running that through a bioinfiltration swell to reduce volumes as well as help deal with some of the metals and things like that. A more recently completed document that actually is not out yet but should be shortly is guidelines for evaluating and selecting modifications to especially the ultra-urban environment, which is a very difficult environment. So again, and Scott brought some of these points up, that particularly in downtown situations, you have very limited right-of-way. The land costs are really high. Utility conflicts. Often there's subsurface condition issues, either geotechnically or from a pollutant standpoint, and all the rest of the things that I'm showing on here. So it's very difficult. And so what the guidance does, and this kind of lays out the sections in it, but it says, let's go through some fundamental steps. So, what are the issues of concern? What are our objectives? Then developing retrofit alternatives, and then conducting an assessment of the practicality, and then ultimately leading to the selection. So it includes spreadsheet-based sizing tool that, it's not good enough for design, but certainly would be good enough for, pre-design and narrowing down the options. So again, that'll be some good guidance for folks. And then another effort that actually Mike Barrett's been working on is looking at, particularly in dissolved metals. And I can tell you from an endangered species standpoint in the Pacific Northwest, both dissolved copper and dissolved zinc are big issues for salmonids. And so, that'll be guidance coming out towards the end of the year on specifically enhancing the performance of BMPs for addressing dissolved metals. And then just to wrap up, there's several efforts on the NCHRP side, several efforts coming up. I've listed them all here. I won't talk through all of them, but again, looking at pollutant trading all the way down to how one might think about dealing with bridge deck runoff. So I wanted to wrap up with just some thoughts about how we might be able to improve things. And there's a WRF effort underway right now to look at highly distributed real-time controls. And what this effort is trying to do is demonstrate that by the use of some smart controllers out there, we might be able to enhance both existing infrastructure as well as any new infrastructure or BMPs that we put in place and improve performance. And so what do I mean by a distributed real-time control? You might have a data logger with the cellular telemetry as essentially the heart or the heart and the brains of this thing. It would have a connection out to the cloud, so it can incorporate rainfall forecasts and the rest of it, as well as field sensors. One could access that from your desktop, and then that could be used to drive some sort of valve system, so you could actually smartly discharge systems. And that's being tested on a number of BMP types. I've just listed the ones here that are more applicable for highways. So you could have a controlled underdrain and a bioretention system, for example, that would say, small event, I'm going to let stuff stay in here a little longer, treat it a little better. Larger event, I'm going to let things flow through a little faster and treat more of the runoff. You could change the way an extended detention system, whether it was a wetland or, say, a retrofit of a flood control basin, you could change the way that operates, maybe take advantage of the space in the flood control basin, but if a flood event is coming, you drain it and get it ready. And it's also looking at some other BMPs down below, but I won't go into those. So here's an example on a controlled underdrain. So down on the right-hand side, there's actually a little valve that could be smartly opened and closed based upon the flow conditions within the bioretention system, if you had a flow meter or depth meter of some type, or could be informed by rainfall or other things from the web. And here's an example that's going to be a real example out in the Kansas City area of taking a wetland forebay, which would then actually be drained down prior to a rain event coming, and then making that extended detention volume available. So it's, again, sort of making some of the green infrastructure work smarter. And it's pretty simple. You might have an outlet structure that's basically just a sluice gate that would open and close, being driven by the controller. So this is an effort. About 20 sites around the country are being evaluated. It's very cost effective, a couple grand for the instrumentation and the rest of it. And if you could take a couple grand and take an old flood control facility and make it work harder, it might present some really nice opportunities. So in summary, we've got some great NCHRP guidance out there for folks to help with these efforts, as well as some emerging technologies. So now I want to turn it over to Lee, and he's going to talk about Washington State DOT's approach to this. And I'm going to take just a second here to transfer control, and hopefully it'll work this time.
Okay. Yes, my name is Lee Nguyen. I'm with Washington State Department of Transportation. So most of my job function is working together with project office to help them to deliver the project. Trying to move to the next slide here.
Yeah, I think just hit your down arrow. I can see you're moving the mouse. So. Okay, I'm going to do it for you.
Okay, next slide. Okay, what's the issue? I think Scott and Eric already mentioned about a lot of the drivers for the requirements, so I'm not going to talk much about it. And also Eric already talked about the pollution removal unit process, so I'm not going to talk about that either. What unique about Washington State is the pitch issue. So due to the pitch issue, that we are forced to remove pollutants to a really low level of concentration. Next slide. So in Washington, basically we have two types of treatment BMP. We have a basic treatment BMP, and then also we have an enhanced treatment BMP. The basic treatment BMP is mainly focused on TSS removal. So we can remove 80% of the sediment. That would be good. The enhanced treatment BMPs mainly focus on dissolved metals, namely copper and zinc. So in order to qualify for enhanced treatment BMP, the BMP have to be able to remove at least 30% of dissolved copper and 60% of dissolved zinc. And some other locations we are required to remove phosphorus and oil also. Another requirement that we have here in Washington is in the Puget Sound area, we have to provide provide treatment to the existing impervious area also. So anytime we have a new project, we have to provide treatment and flow control for the new impervious area, and then also we have to provide treatment and flow control for the existing pavement also. Next slide, please. Oh, I think, okay, that's good for this one. So the challenge on the first bullet there, I think the challenge that we have is kind of similar to other DOTs, so it's not much of a difference of physical constraint. Most of the projects are located in the highly urbanized area. But the unique thing about Washington State is we have only, not too long ago, we have only about 3 enhanced treatment BMP, a kind of fractal enhanced treatment BMP, namely the stormwater wetland, the media filter rain, the logistical ecology embankment, and the compost amendment bed state filter strip. And luckily, lately we just developed a new one called compost amendment biofiltration well. This one is kind of just a regular typical bios well, but we put compost amendment soil on top of the existing soil, and we till it in with the existing soil. By doing that, I think it can remove dissolved metal better than a regular bios well. Next slide. Okay, as you can see here from this picture on the right-hand side, we have a really tall retaining wall, and on the left-hand side, we have a steep embankment. So when projects are in this kind of location, technically it's very difficult to find a good location to put a treatment BMP anywhere here. Not only that, we have multiple airports throughout the Puget Sound area. So if it's near the airport, I think the rule is we cannot have any open pond, like wet pond, or the stormwater wetland within 10,000 feet of the airport. Next slide. Here, if you look at this, the challenge is more difficult to deal with in like a highly urbanized area, interchange area like this one right here. As you can see that multiple flyover ramps crossing one another. So there's no good place to put a treatment BMP anywhere. There's no embankment next to the structure here, so we cannot really put a college embankment or stormwater wetland here. So at some location it's not like this, and at some location we have a really flat highway, and we are facing another issue that sometimes we have an existing wetland on both sides of the freeway. And then also that here in Seattle, I think it rained a lot. So we have a high groundwater elevation at most locations. And that would be a challenge for us also. Next slide. So how WSDOT is going to overcome this challenge and meet the environmental requirements? I think that as I mentioned before, we have only a few enhanced treatment BMP available in our stormwater menu. And sometimes at certain locations, those BMP cannot really applicable due to a physical constraint or any other issue that we cannot use it. So we are forced to come up with a kind of like a custom-made BMP. And just like Eric mentioned before, we develop a new BMP based on fundamental of hydrology, hydraulics, and pollution removal unit process. So this BMP that is not in our menu, I don't think it would be any stormwater menu in the nation. And when we develop this BMP, I think the solution, I think that we need to work together with the other stakeholders and invite people come to the design table so everybody can have an input and buy up from the BMP. Next slide, please. With that, I would like to introduce to one of the projects that we have to come up with a kind of custom-made BMP. This project is located on SR 303 in City of Bremerton in Washington. It's a managed bridge replacement. So if you want to know more about this project, you can follow the web links here. So this bridge is about 1,600 feet long, and the current bridge receives no treatment at all. Next slide, please. And then when we build a new bridge, the city engineering manager asked us if we can develop a new BMP, follow the LD requirements. And then I think on top of the treatment BMP, I think he would like to create like a city park that people can sit there and have lunch and look out to the bay. And the allocated location for this treatment BMP is only about 50 feet by 50 feet. And if you use infiltration BMP, you should require a really large area. So 50 by 50 is not feasible. And then also, I think we have to get everything done by 1 month or so. Next slide, please. So here you can see that the treatment BMP is kind of like in the middle bottom there. It's located in a really steep embankment, 2-to-1 slope. And the infiltration, if we have to meet the infiltration requirement, then we have to put in a treatment soil layer that have like an infiltration rate of 2 inches per hour or so. And if we're doing that, I think the surface requirement would be much larger. And as you can see here in this hatched area, the treatment BMP is located right next to the roundabout, and then on the left-hand side is the bay. So people can sit there and have lunch and look out to the bay. Next slide, please. This takes a while to move. Okay, here is the cross section of the treatment BMP. So basically, at first, I was trying to design this as an infiltration pond or infiltration trench, and by putting rock in there. But the void ratio of this rock is about 30%. But since the location is too small, so I have to bring in the arch pipe to get additional volume for the treatment volume. And then underneath this rock, we put in a 2 feet of compost amendment soil to treat the water, and we compact it a little bit to make it have like an infiltration rate about 2 inches per hour. So when the water go in here, mostly will stay in this arch pipe and then kind of go around and percolate into the rock area, and then will gradually infiltrate into the subsoil to treat the water. So the overflow water will be collected and connected to the city system. Next slide, please. This one is just the plan view of that treatment BMP. Yeah. Next slide. This one is a different project. This one, an I-405 corridor program, is a HOV lane widening. The entire corridor is about 30 miles long. It goes to 5 different cities located in a highly urbanized area. And I think we estimate the construction cost for the BMP is about $1 billion. There are many existing wetlands in this corridor. Next slide. So we were struggling to fulfill the environmental requirement for this corridor because we have a very limited up enhanced treatment BMP. And on the left-hand side, you can see that would be a typical cross-section for the medial field terrain. In order to use this cap BMP, the embankment slope have to be like 3-to-1 or flatter. It's about 33%. And most of the location here in this corridor, I think it's got deeper, like 2-1 or so. So we cannot really use this cap BMP. So we were thinking, and we came up with a different cap BMP. We still use the same material of the medial field terrain, but we modify a little bit. Instead of putting next to the roadway embankment, we collect all the water and convey it to different locations of the roadway and spread it out using a flow spreader. Next slide, please. So here you can see on the bottom there, we capture the area and we bring it to a different location, spread it out, and treat the water that way. Next slide. So over here on the top, you see that would be the cross section of the modified medial field terrain. The water will bring in and then go to an 18-inch per pipe on the left-hand side there. And the water will percolate, go through the flow spreader, and it go on top of a 4-foot section of the RAS, and it flow onto the 12-inch of medial field terrain. And when it go to the right, we'll collect all those treated runoff using a 12-inch per pipe and discharge it at the appropriate location. Next slide. I think this one is kind of the same as the previous one. It's just so close-up detail of the flow spreader. Next slide, please. So over here is our final product. As you can see that we install a multiple monitor equipment to monitor the inflow and the outflow and to monitor the pollutant between the in and out flow. And when we monitor this, I think that we observed that with this cap BMP, it was able to remove 36.6% of dissolved copper, and it removes 64.6% dissolved zinc and 94.5% of the TSS. So with this removal percentage, I think it meets the enhanced treatment requirement. And over here, you can see that there's no place to put any treatment BMP. So the modified treatment BMP that you was looking at is located between the highway and the building there. Next slide, please. Over here, so the detail about how that flow spreader is constructed. So on the left-hand side, that's a 4x4 post, and we are using like a 2x8 or 2x10 of the bore for the flow spreader, and we cut a V-notch at every 2 feet in the bore. So all this material are recycled plastic. Next slide, please. So I think one of the things that I want to mention about flow spreader is it's very easy to draw a straight line on paper and say it's a 200 feet long, 0% slope. But when we build this flow spreader this long, and even the notch elevation is kind of different, about 1/4 of an inch, the water will concentrate in one location and not spread out the entire length of the flow spreader. So the DOE say, no, if we're doing that, we are not meeting the requirement. So we have to go back and make adjustments so many times. At one time, I think we have to remove the entire length of the flow spreader and build a new one. So it's not very easy to keep all the knots at the same elevation. So from what we learned from this one, I think that we want to minimize the flow spreader like to a maximum of 50 feet or so. So that's easier to control that way. This will be a final product here. After we build, we bring a water truck out there, and you can see that on the right picture, some of the water is concentrated in one location and not spread out the entire length. But eventually, I think we fix it, so it works now. Next slide, please. Here, so some of the detail during construction, how the water flow from one side to another. Next slide, please. This is the final product. So if you look at the picture when the man was sitting down right there, on the right-hand side, which you cannot really see, is an 18-inch probe pipe, and then you can see a V-notch weir there. It will go over top of that weir, and it go over another like a couple feet or 1 feet of the rubble section, and then it go over a 4-foot section of the rack, and then it go to a treatment meter filter range there. And then on the left-hand side, there will be a 12-inch probe pipe underneath that you cannot really see there. So again, what we're seeing here is a treatment BMP that is not available in our stormwater menu, nor probably not in any of the stormwater menu in the nation. I want to talk a little about the cost and maintenance for this kind of BMP. So most of our projects here in Washington are design build projects, so we don't have cost breakdown for each item. But I think that the modified media filter range footprint is much smaller than the typical media filter range. A typical media filter range is located along the embankment, and the treatment surface area over the roadway surface area is about 1.5 or 1.7. With the modified media filter range, the footprint over the roadway surface is about 1/30. So it's much smaller than the typical modified media range. So by thinking it that way, I think it will cost less to build the modified media filter range. And since off the roadway, when we maintain it, we don't have to close the lane, so that will be less for traffic control. So we cost less to maintain the modified media filter range. Next slide, please. So the lesson learned that we learned here in Washington is we are facing a really stringent requirement, probably more stringent than other state DOT due to the this issue. And most of our projects are located in a highly urbanized area. So there's not many BMP that we can use in our stormwater menu. So we are forced to come up with a custom-made BMP. And by doing that, I think we have to work together with other stakeholders, invite them to the meeting, seeking their input, advice, and get a buy-up for those kind of BMP. Next slide, please. I want to mention a little bit about the national research project. So since we have only a very limited number of treatment BMP, we are currently working with the National Cooperative Highway Research Program on a couple of projects. So one of them is Eric and already mentioned is 2532. That research project is to develop new BMP that can remove diesel metal effectively in a highly urbanized area. And the other one that we're working is 2542, which runoff treatment analysis and treatment options. Michael Barrett is taking it, and Eric on the research team for that one. With that, I will conclude my topic today. And I post my contact information there. If you have any questions, you can email or call me. And thank you for listening.
Thank you, Lee. That was great. So our next talk is going to be by Dr. Michael Barrett from the University of Texas. He's going to talk to us about porous pavement overlays and their potential for addressing highway pollutants. And Mike, I'll try to see if I can't hand this over to you, but we'll see if it works. Why don't you go ahead and give it a shot.
Black flash. There we go. At least my mouth is working. Well, I'm here. I'm going to tell you guys a story about porous pavement overlays, and it's a particular interest for a couple of reasons. One is that it's a BMP that it seems virtually no one has ever heard about. And the second interesting thing about it is that it is specific for highways. It's a BMP you can't use on any other land use at all. So it's our own little special BMP. And let's see if this slide changes for me. Seems a little slow, Eric.
Yeah, no, it's actually not changing here, so for whatever reason. So your mouse works, but the slide doesn't advance, so I'll do it.
Okay. So what we're talking about when we talk about permeable friction course is a sacrificial overlay, like you see here in the left-hand picture. So it's about a 2-inch thick overlay on top of conventional pavement. So when it rains, what happens is that the water goes right into the pavement until it hits this boundary with the conventional pavement underneath it. It's impermeable, and then the runoff appears as a seep along the edge of the road. And so, and what that does is keeps really a lot of the water off the surface of the road. So we're just talking about a thin lift porous overlay, and the reason DOTs are comfortable with it is that you have the impermeable layer underneath it, so it's not a fully porous section, and so there's no concern about base materials getting wet and strength of the roadway and all of those kinds of concerns. Next, Eric. So how do you make PSC? In this bottom slide, each of these columns represents a amount of aggregate retained on a different sieve size, from really coarse here at the left to very fine at the right, and here the asphalt binder. So to make PSC, what you do basically is get rid of all the fine material, and all the aggregate is in just a couple of size fractions. So you end up basically gluing together gravel, and that's why it's so much more permeable than conventional pavement. Next. So why do DOTs like it? And the main reason is because you don't have the water on the surface of the road. You get rid of splash and spray behind vehicles. You reduce the depth of water on the road when it rains hard, so there's less hydroplaning chance. Are you going to screw me up by taking away my bullets, Eric? But anyway, here's a picture of the splash and spray. And so on the right-hand side, here's a truck on PFC. And you can see up here in the distance this boundary between the PFC and conventional asphalt in the distance. And so we're following this one truck, and here's in the picture on the left, we're just following that same truck right around the corner on conventional pavement, and you can see all the splashing and spray, and the visibility is terrible. You can see all the reflections of the headlights and how you can barely see the stripe on the road. So it's just a night and day difference driving in. And in fact, PFC is widely used in Holland, and the Dutch use it primarily to reduce highway congestion, because what they found is it rains all the time there, and people drive faster when they have good visibility, and congestion is thereby reduced. Next one. So you're probably thinking, well, we don't have PFC here, but in fact, except if you're in the upper Midwest or parts of the Northeast, you actually do all around the West Coast and through the South, even up through Michigan. And some of the concerns early on about porous pavements were really about freeze-thaw and will it fall apart. And Indiana did a recent 5-year study and found that after 5 years, basically the condition was the same as conventional pavement, which led to both them and Ohio adopted it, and Michigan's adopted it too. So it's actually a widespread material included in standard specs in the majority of states. Next. And so we were doing a study actually for TxDOT, and you can see the PFC on the right side, the coarse dark material, and then the conventional asphalt underneath it through this area. And we were looking at pollutant removal and vegetated shoulders, and TxDOT came in the middle of our project and did a PFC overlay, which at the time we thought was a huge pain because we had to take our equipment out, modest as it was. And after they did the overlay, we came back and we started monitoring again. Next. I think you have to do 2 here. There we go. So we started monitoring, and this data here in red is from the conventional pavement, and then we took out our monitoring equipment and came back and started monitoring again, and all of a sudden we went from concentrations that were a little over 100 milligrams per liter to concentrations that were less than 10 milligrams per liter. And we thought, well, man, this is special, but is it just because this pavement is brand new and it's clean or whatnot? And so we said, TxDOT, give us another year of money and we'll continue monitoring and see what happens, see if it persists. And that's the data that's appeared now. You can see what happened in that additional year, that it kept going, and we kept thinking, well, it's going to clog and the water quality is going to get worse. And we said, oh, TxDOT, give us 3 more years. And so we continued going along, and you can see that through the whole length of the study, the quality of the runoff, for at least for suspended solids concentrations, maintained, an average concentration of less than 10 milligrams per liter. And finally, TxDOT said, enough is enough, and why don't you find another project to work on? So the next slide. Here's a summary of the concentrations, and so you can see for TSS we went from 118 to 8.8, a 92% reduction. I know Eric hates the percent reduction, but in Texas, in this area, the regulatory criteria for stormwater treatment is to achieve 80% removal of TSS, and here we were getting 92% removal. And so the implications for the TxDOT were huge, which meant that all we had to do is take a pavement that we're using already, and with that, we can achieve all the water quality standards without building anything, buying any right-of-way, doing any maintenance, no nothing. And so you can see we also had substantial reduction for a number of these other constituents, mainly those associated with particles. Next. And so you thought, well, that's unbelievable. So let's do a side-by-side test. And in this picture, the concern about PFC is that when you remove the fines, it loses some structural strength and tends to ravel, especially where there's sharp turning. And so you can see TxDOT in this case left the intersection conventional pavement, and then here's the boundary between the two. And then this is PFC down here, and we installed these passive samplers, one here and one up here, only say 100 feet apart, and we could collect samples from the same event. Next slide. Slowly but surely. And so here's individual events from the conventional pavement runoff in red and the PFC in blue, and you can see very consistently for every single event that the suspended solids concentrations are a fraction of the concentrations in conventional runoff, even though these two sites are like 100 feet apart. Next. And again, you can see at this side, we're achieving something like 88% removal of TSS, so we kind of confirmed, yeah, we're above the 80% threshold, and again, good removal, especially the total metals, not as good on the dissolved metals. Next. So in the end, we did 3 sites for TxDOT, and here's a box plot of our data. So this is the conventional pavement grouped together for all 3 sites, and you can see the median concentration is around 130 milligrams per liter or something. And here's the quality of the PFC runoff from the 3 sites we monitored. The median concentration there was right at 8 milligrams per liter, so a huge difference for sites that are right next to each other. And roughly coincident, Bill Hunt in North Carolina started to do a project monitoring the improvement in runoff from vegetated shoulders, exactly what we were doing before, actually. And he didn't realize that the pavement was PFC, and he got out there and started monitoring. All of a sudden, the runoff at the edge of the road was super clean, and of course, he got no improvement after it went through the grassy area. But so from these 4 sites in North Carolina, all on I-40, his concentration, again, median was less than 10 milligrams per liter. And then finally, I kind of lobbied Caltrans that they needed to look at this, and so Caltrans monitored quite a few sites, some permeable, some due to age or clogging or whatever, not permeable at all. And this is the data for the sites that still maintain substantial permeability, and they too had concentrations of TSS under 10 milligrams per liter. So we've got now data from East Coast, West Coast, Gulf Coast, all demonstrating you can get very substantial reductions in suspended solids and other constituents. And so we took the California data, and also in California we'd done some monitoring of sand filters for Caltrans years ago. We had 5 sites. And in this table I'm going to compare the discharge concentrations for sand filters from that Caltrans study, which are in this column and these 2 values, to the discharge concentration from the permeable overlays, which in Caltrans speak is OGFC instead of PFC. And this is a list of constituents for which a sand filter will achieve significantly or statistically significant reductions in concentration. And what you can see is for every one of these constituents, the concentration from the OGFC is less than the corresponding concentration from a sand filter, except for TSS, where the differences aren't statistically significant. So the bottom line here is, look, you can get the performance out of a sand filter by just paving your roadway and calling it good. A question that comes up all the time is, well, if it's removing all this pollutants, they're going to accumulate in the pavement, so it must be going to clog, so how long does it last? And the data that's kind of filled in here is our sites, which we started when the pavements were brand new, up to about 5 years old when TxDOT said enough's enough, compared to Bill Hunt's North Carolina data, which is the open symbols, and his pavements were all pretty old. So he was getting water quality exactly the same as ours in pavements 9 to 10 years old. And for the North Carolina DOT, they considered 10 years to be the effective structural life of the pavement. And so in the middle of Bill's study, they went out and milled them and replaced the pavement. And so here's additional monitoring from Bill with brand new pavement. So what this says is that under the right conditions, and remember Bill's was on an interstate, similar to some of our sites, that the water quality benefits last for as long as the pavement lasts. And the amazing thing is that no one is doing any maintenance at all. There's no street sweeping, there's no flushing of the pavement, there's no nothing. This is install the pavement and walk away. Next slide. So how do we get such great water quality out of a little teeny 2-inch or 1.5 inch thick overlay? And the concepts are, one is we got rid of the splash and spray because there's no water on the surface of the road, so I'm not washing my engine constantly as I drive down the road. So I got a little source control component. The other thing is the surface of the roadway is super high energy environment. You're splashing your way down the road in a rainstorm. You're really moving stuff over to the edge of the pavement and the gutter, so it's easily transported. And within the porous overlay, I mean, that's a pretty quiescent setting, and so the water moves pretty slowly, so things just don't move quite as well, and you can't carry the size particles that you could on the surface of the road. And finally, you've got potentially filtration and sedimentation and stuff occurring within the pavement itself, so the treatment component. And I kind of go back and forth about which one of these bullets is the most important one, and I kind of lean towards the latter now. So we're doing some monitoring here now. I have my student Laura in the office with me, and she's monitoring 2 sites on a freeway here in Austin, Mopac. And the interesting thing that these are, first it's wider, so it's 4 lanes instead of 2 or 3. It has curb and gutter instead of a rural cross section. And so we're still seeing really good water quality. Still at the good side, we're still getting exceeding 92% suspended solids removal. And the other thing we're seeing is on the right side, this pavement incorporates recycled rubber in the asphalt binder, whereas the pavement on the left does not. And as Eric mentioned about zinc and tires, we always see substantially higher concentrations from the side with recycled rubber in it. And what we're doing now, and I think we'll try and do starting in the summer, is look at some amendments we can do to the pavement of like adding sorbents in the pore space so we can get improved removal of dissolved constituents, primarily metals and possibly dissolved phosphorus. Next one. Probably next one. So here we are. So the idea is look, here's the pavement. The water quality of particulate-associated pollutants is fantastically better. You know, you're seeing 80 or 90% lower pollutant concentrations. And the trick is DOTs are using it all the time. I mean, it's in all of those studies in North Carolina, California, and Texas, none of those were installations specifically for water quality testing. Those were all sections that the local DOT or district offices had done on their own accord just because of the safety and noise benefits. That's my other bullet I forgot before. It's quite a bit quieter. They just did a redo of the freeway through the Austin that goes through a lot of residential areas, and there's a 7 decibel drop in noise when they did that. A downside is that there's not much volume reduction. There's some delay in peak and attenuation of peak at kind of modest rainfall intensities, but if you're under a real LID scenario, it may not be something that gets by the regulator unless you have no other options. And the key thing here is that a lot of constraints have been mentioned by the other speakers. Sound walls, limited right-of-way, you know, elevated sections, etc. This requires none of that. You're just going to go out there. If it's an existing asphalt pavement, you're going to mill it and replace it with PSC. If it's a concrete pavement, you're going to do a seal coat and then an overlay with PSC. And so there's really, you don't have the ultra-urban constraints. And finally, you know, it's actually a little more expensive, but in my mind, it's free. The DOTs like it as a better pavement. They're starting to use it more and more widely with absolutely no knowledge of the environmental benefits. They're doing it primarily for the safety, visibility type reasons. So I see the water quality benefits you get for free. So the questions that people ask, a lot of states, they kind of thumbs down on OGSC. And the early designs, they have problems with the binder because you have the really permeable mixture with no fine materials. The binder tended to drain down to the bottom, and then the pavement ravels. The gravel on top comes loose, and everybody hated that. The Europeans improved the binder mixes, and now they have polymer modified binders and fibers and stuff, so drain down's not the problem it was. There's still a variety of mixed designs among the states, however. The maintenance thing, nobody is doing any maintenance. As I mentioned, Bill Hunt's pavements lasted their entire structural life, providing water quality, never swept, nothing. The cost, a little bit more, because you have a little higher quality aggregate because there's fewer grain-to-grain contacts, the aggregate has to be stronger. In the study in Indiana said freeze-thaw, not a big deal, but as you could see in the map, there's people in Wisconsin, Minnesota, and North Dakota, and places like that that are still concerned about it, although it has been widely used in Europe like France, Italy, Holland, Denmark. So it does work in winter conditions. And the downside for if you get a lot of snow ice is that it requires more frequent application of de-icers. So if you're in the chloride mode fighting that, then it may not be the silver bullet for you. And here's 3 articles that you can go back and get later in case you want to talk to your regulator about this and want to be able to say more than I heard it or saw it on the internet. Here's some peer-reviewed articles, the first 2 about water quality. The second of these including an introductory to the hydraulics, the drainage in these thin lift overlays. And then the last one, a heavy-duty hydraulics modeling thing, only for the mathematically proficient, I would say.
All right, thanks, Mike.
So I think I'm done now, right? All right.
Yeah, you're done. But we're going to bring you back for the question and answer period. So that reminds me to remind the audience that you can submit questions at any time on the sidebar over there. I think I've seen a couple come in, but it'd be nice to have a few more. So far we've heard about some of the challenges and regulatory issues, and then some of the tools that are out there, and then specific applications of some of the tools and emerging tools. And so the other part of this is making sure that all this stuff keeps working. So with that, Peter's going to give us a presentation on asset management and keeping track of VMPs. So Peter, I'm going to try to give you control here again. I may have to advance the slides for you, but at least with the way it's working, you're able to employ the mouse in terms of moving it around and showing people things. So why don't you go ahead and hit see if it goes forward.
Okay, give it a try. I can see my mouse. Let's try the.
Well, I'm going to go ahead and do yours too.
Yep. Thank you. All right, I'm Peter Matajet. I'm with the Maryland Transit Authority. I oversee the MPDS program, which is pretty much in a nutshell a lot about the BMPs. And we're growing leaps and bounds. We have a lot of new ones, particularly from our mega projects. And then also a lot of new ones coming in proposed for the Chesapeake Bay TMDLs. So what now? I mean, you have all these in the ground, and there are a lot coming. So asset management is a way to be able to strategically manage these BMPs for your long-term benefit. And everyone needs to recognize we want to minimize our costs also. So this asset management is holistic, is geared towards know how to manage, operate, and maintain infrastructure. And really does integrate not just engineers, but planners and operations, and recognizing costs to basically realize how to be cost-effective and basically to reliable performance. And by the way, we're also trying to get the check marks with our compliance. And basically, the asset management is the principles are in one: inventory, pretty straightforward, knowing how to do evaluation on the conditions of your BMPs, knowing that you still have to do some remediation, and then tracking all that. Thanks. Great. So I'll be focused on the principles. So the first one, inventory. Give a quick overview. Basically we're collecting both spatial and attribute data for our BMPs. And it's very important to understand how BMPs function. What's the storm management? Is it treatment for water quality purposes? Is it water quantity or even reduction of volume? Knowing that how they perform is important. And knowing that our stormwater designs keep evolving. We have some legacy ones from pre-2000 that are very much outdated compared to our new regulations. And then knowing that this all rolls into our stormwater MPDS program. Next. And I like how Scott put in there about, well, this is interstates. We know they didn't have storm management. Well, we have some from the late 80s and 90s where they were traditional. They were highly distributed, sprinkled along roadways. But there was a conventional approach of, we're just collecting some stormwater, conveying it in, treat it at the end of the pipe, typically linear. Now we're really getting geared towards looking at things on a watershed approach, integrating them in roadway drainage systems, use of BP trains. We're getting all kinds of BMP types out there now that really change the dynamics here. Next. All right, just to get everybody on the same page, I try to always look at what are the major BMP types. You have your ponds and wetlands, infiltration devices, and then filtering devices, and some permeations there, but then you have your subtypes under there, and it's important to know that ponds also comprise wet ponds, dry ponds, vent attention. Infiltration devices could be multiple things, from small trenches to large basins, and filtering devices particularly have a whole kinds of variety of them. Okay, next. And one of the things is each BMP, whether they're simple or very complicated, there's always some BMP data, the spatial data, the outline of the BMP, as well as the components. You have your forebay, your risers, various structures, and it's important to understand that we have drainage areas affiliated with each of these. And I always like to stress that asset management is also managing all your documents. You have quite a few design documents from plans and reports. Along the way now we have a lot more access to aerial imagery and photos. Okay, we jumped ahead. Okay, and all that's good to take advantage of because it's used to develop the inventory as well as leverage it when you do your inspections and your remediation. But more importantly is that really data does not stop there, and including now watersheds and particularly TMDLs, as Scott was really reinforcing there. We really have to look at things on pervious area treated. With TMDLs, we have to have pollutant loads and the respective reductions. And one thing I'm looking at is that we're not only taking care of what's BMPs in the ground, we want to know what's proposed so we can keep ahead of the game. Next. That being said, let's get into the condition evaluation.
the overview is basically you're trying to just assess your condition, and it's a combination of not only its stability as its standing, but also its stormwater performance. And as I stressed earlier on, you want to know, can only evaluate based on the type of design. A pond definitely functions very different than an infiltration device versus a filtering device. Inspections are also geared towards recognizing your remedial needs, but the value of it is that as you collect data over time, it's going to give you some long-term data to work with. And as needed, you may need to do some detailed assessments. You may need to drill down to a specific site that's problematic, or you may be looking at different BMP types. For example, infiltration devices. Sometimes, we put them in the ground thinking it's a great spot, and sometimes they don't work out. And then, detailed assessment can also be including using wet weather monitoring to help evaluate your performance. Now, I'd like to stress that, inspection is great, but come up with a really definable protocol that's reliable and repeatable is very valuable. I've utilized defining parameters focused on BMP elements. For example, there's site-related ones, and then there's ones that are specific to stormwater management, vegetation, the type of riser or control structure you have. Those are all relevant, and we tend to, try to score them from 1 to 5, from good to bad. And all those parameters then could be consolidated to come up with an overall rating. Again, good to worse. What's good about the rating, you can relate it to not only the condition, but potential remedial actions. And all the while, inspection is always collecting data, scores, measurements, for example, of ponding that's additional in the pond that shouldn't be there, comments both on a site condition as well as comments that can be utilized for remedial work orders. Same thing with field photos. You want to take pictures of site so you see it over time, but also define specific defects. Next. And here's an example of a rating schema. Not that complicated. Go from A to E, good to worse. A being functional, basically nothing needs to be done. B, you're seeing some flicker of things. Maybe it's an indication of maintenance is needed. But then, C, you're starting to see some moderate issues with multiple parameters. You start recognizing some remediation might be needed. You start thinking about either scheduling it sooner or maybe for the long term, but recognizing that you just can't ignore that. D is where you have major problems. You might need to be accelerated. Then E is geared towards, it's not functioning. It could be also a safety issue because the stability is compromised. Next. All right, so the inventory inspections all help you to keep track inventory, but now remediation, you have to do something. And really the objective here is to maintain and performance or restore stability. And that's why you focus inspections on those type of things. Remediation is not only based on inspections, but they could be scheduled activities. So I'm going to walk you through some of the different types. For example, corrective. I essentially consider that a lot of BMPs out there that were, let's say, just gone wild. They have just never been maintained. It's important to understand it because you're going to spend a good chunk of money for making up for lost time. But once you get it up and running, then you're at the stage of, scheduling routine maintenance, which is, I define as an activity that's annually. It could be once, seasonal, whereas cyclical, they're geared towards a multi-year intervals. For example, routine might be the mowing, whereas cyclical might be cleaning out the forebay. You have to do it sooner or later, and then you can basically monitor through your inspections. And then recognizing, with age, eventually you do have to rehabilitate various components or entire BMPs. And then also is recognizing, particularly with our older BMPs, that become obsolete or really aren't considered effective any longer, and you have to go through a process of enhancing it. And either way, all these activities can be done under a kind of work order format geared towards pretty predefined punch lists, activities, and annotating the plans and maps and photos really show where the work has to be done. And one thing, though, can fail to recognize there's a lot of other things. You got to deal with traffic, utilities, environmental resources, right-of-way, ENS. These are all need to be considered in the costs as well as activities. Next. And here are just the components of a work order. Basically, we come up with a standard punch list, and we have defined categories. We utilize the existing design plans and annotate them, recognizing, we put 1, 2, 3 for the punch list. Also, the aerial imagery can be another way to do that in photos. And one thing I like to stress is keep it simple. This is basically a parts list and directions how to solve the problem. Okay, next. Yeah, and again, I got to stress, if you don't forget the details, utilities, we got a fiber optic right under our pond. I'm not sure if that was the greatest idea, but we had to recognize that before we started digging out into the forebay. ENS, always making sure you can dispose of any kind of dirty water that's treated. And then definitely, we're all in about interstates, and MOT, from the smallest activity to the biggest one, we have to pretty much be very cognizant, and occasionally sometimes some of the BMPs we have out there are pretty much tied up by having way too much MOT, and that's kind of one of our parameters for the future for retrofits or enhancement or abandon. Next. So here's kind of examples of one, the corrective maintenance one on the left, and rehabilitation. The corrective maintenance required quite a bit of removal of vegetation, sometimes invasive species management, and then basically restoring it back to what it was. This is one of our earlier designs, so basically, like a better word, like a hole in the ground. Then whereas the one on the right is the rehabilitation of an infiltration trench, where we removed all the media. And you can see in both cases, there was quite a bit of stabilization required when we closed out the project. Okay, next. All right. Stress how we got inventory, you got inspections, and you got remediation now. How do you track all this? You're continuously collecting data to help in decision making. You have to maintain that data. Even with inventory information, sometimes you'll find new data to update it. Conditions is always cyclical information, as well as remediation. And remediation could be like one big work order, or could you have multiple things going on and having to track it. And then all those activities include cost data of some sort, labor, materials, equipment. Then you're managing not only existing BMPs, but preparing for pending ones and planning out their future ones. And I can stress that one thing about our inspection program is, boy, sure helping us teach us how to design better future BMPs when it comes to operations and maintenance. This is just a very simplistic workflow. It's recognizing just collecting all the data is not to start, but then you get work orders and sign them. For us, we look at our maintenance staff. We have contractors, and we have other vehicles for getting people to do the work, and then you can see, keeping track of that, all the documentation from the remediation needs to be consolidated and brought back into the GIS. And I can't stress enough that it's really requires quite a few bit of coordination with your operations people. Okay, next. Okay, not to scare everybody, but here's our GIS. It's typically the primary tool to consolidate your information, but recognizing it requires quite a bit of investment. This has been developed over time, where we've included also our drainage infrastructure and all NPDES components like illicit discharge. But if you're really going to get into asset management, these are the kind of things you have to consider before you get started. Next. I'll break it down a little bit, particularly the GIS model is geared towards, when it comes to BMPs, you have spatial data as well as attribute data. As I mentioned, it's both inspection and remedial records are cyclical, so you're going to be collecting a lot of those over time. One of the things, though, is when you start using GIS or databases, you can use standard pull-down lists. It really helps to keep consistent data capture, both for comments on a facility or for remedial activities. It really can help streamline and keep your record tracking straight. And also, we use the GIS model to link with all our documents. Particularly when we get into enhancements, we want to know what the original design was, pull out any design data that can help us move quickly into a redesign instead of starting all over. Okay, next. Yeah, I've stressed how it's GIS, and GIS software is not for the faint of heart, because it does take quite a bit of expertise. You utilize it to create, edit, query, and view data, as well as manage documents. We went to great lengths to build a very effective GIS. Next. Widoli also developed a GIS enterprise, and this is a pretty neat. It's a Google Earth enterprise. We're able to bring in layers on and off as we need. We have all our other information from utilities right away, all consolidated. So as a manager, I can rapidly look at different BMPs, zoom in, zoom out, without ever having to be a GIS geek, which is a pretty effective way to manage your assets. Next. And I'm going to highlight that the fact is once you collect information over time, you have the ability to really look at things, either performance of individual BMPs over time. With asset management, as you do remediation, should be restoring quite a bit of your performance. Here, we do absolutely look at very closely at our different BMP types, and we find our infiltration devices tend to be more of the high maintenance child of all of them. But that's one of the things we deal with. Having a linear roadway, linear infiltration trenches were very popular in the 90s. So you can see that once you've gotten several years under your belt, you can start really leveraging this information and also help streamline your annual reporting for NPDES. So you definitely get rewarded by spending time to get the GIS up and running and tracking. And as I mentioned, BMPs keep coming, so this is a tool built to last. All right, done, Eric.
Okay, thanks, Peter, and thanks, Scott and Lee and Michael for their presentations. And in just a minute, we're going to start the question and answer period. So as a reminder, we aren't taking verbal questions just because we have so many people in the audience here. I'm actually still seeing 195 sites up there. So please enter your questions in the pane in the GoToWebinar control panel. It's on the right side of your screen, or should be. If you don't see that panel, just click on the orange arrow at the right edge of your screen, and the panel should reappear for you. So I can see we actually have quite a few questions already, so I'm going to go ahead and jump in and start putting out the questions there. So first one is actually for Lee, and the question is, were there any geotech objections during design to the addition of organic matter within the embankment slope? So that he's applying that to the infiltration, he or she applying that to the infiltration gallery of the embankment slope above the pocket park.
I'm sorry, can you say a question again?
Yeah, was there any geotech objections during design to the addition of organic matter within the embankment slope?
No, not I'm aware of, no.
Okay. It looks like this is a comment. So a comment to Lee also that he said, I can confer Lee's results on TSS and dissolved copper removal with MMFDs. I got as good or better results with a section of US 26 near Beaverton, Oregon. So he says he likes the design, and Oregon's been using that as well. So Mike, Barrett, a question for you. You know, a number of these look great for California or Washington, where they rarely deal with frozen ground. So are any BMPs that work in a winter city-state environment? And I think you addressed some of this already in your presentation, but maybe you could comment more. In particular, in states that use studded tires and how that might work with the permeable coarse material.
You know, I'd have to say I don't know of any states where they're happy with it and they use studded tires. I think Colorado looked at it for a while, and I think there was just too much abuse on the pavement with people driving up in the mountains with studded tires. And the Swifts weren't that keen on it either. So most of what you're seeing is places with occasional snow. And obviously when you look at the map of where people are using it, all across the South and the coastal areas. So if you're in a place like Portland or Seattle, you know, you can be pretty far north and there's very rare that it actually snows all through a lot of California. So when you get into the super cold, you know, the ground's frozen and nothing's running off, and it's always been a challenge to try and figure out what to do there. And even the BMPs that you see a lot in the north, like ponds, for instance, occasionally like in Minnesota or Wisconsin, the performance is quite a bit worse in the spring when you're first getting the thaw. So the winter winter performance is a challenge, really. And so I don't think there's a magic bullet there to go to.
So another question for you was on dissolved. Why was the dissolved copper going up, and how I think you mentioned you're going to look at some ways to mitigate that, but
we found that was I think we didn't find that consistently across all the sites, and so I'm not really positive about what the cause is. It could be that because you're retaining a lot of the total metals within the pavement, then there's more opportunity as new rain comes in to dissolve the copper and leach it out. I mean, we're obviously not making copper in there, so it needs to be a transformation of form. And so, yeah, that's one of the things, not just that it went up at that one particular site or the two sites there, because our other site it didn't go up. And I don't think in California in the data there that it consistently either went up or down. So, but clearly there's a lot of DOTs trying to deal with dissolved metals issues, and it's been a real driver because that's one of the pollutants really associated with highways. And so that's why we think that's a key area of additional research. And I was just the first step I think was just trying to convince people that the performance is real and that you can get the kind of particulate pollutant removal. And now I think it's time that we've kind of gotten to that stage to look at more advanced treatments so that we're including some other processes like adsorption to deal with those other constituents.
okay. So another question was, it looked like the examples you gave were primarily soft edge roadway systems instead of saying, you're up against a retaining wall or a curb at least. So how have folks designed this to work when you have essentially a potential barrier at the edge of the pavement?
It really varies a lot by DOT. For instance, like TxDOT will pave the entire roadway and shoulder with PSC right to the edge. And when they have a curb and gutter section, what they do is they lap it just over the edge of the gutter, so you have about a foot free on the side. I haven't seen any studies yet. I mean, there's really not very many studies. There's me and Bill and a few California sites of like a huge barrier right up against the wall. But DOTs terminate the PFC in a lot of different ways, and like if you look at California, for instance, they only overlay the paved portions of the road, so they do maybe a foot off the traveled lane, and then they taper it, and you might have 5 or 6 feet of conventional shoulder before you either get to the edge of pavement or a curb and gutter system. So our data says with a curb and gutter, you're still good to go, and certainly the California data says that you don't need to pave the entire roadway to get the water quality benefits, but you do need to be, you have to cover the traveled lanes.
Okay. Just so you know, there's a number of folks that asked about whether the presentation will be available, and yes, it will, as a PDF on the AASHTO Center for Transportation site. And I'll have a link exactly where to go to at the end of the presentation. And I think actually the announcement had links that will take you to that as well. So that will be available along with a recording. So if you want to watch it again or get more information that way, you can. So Peter, I've got a question for you. Someone wanted to know what the annual budget for inspection and maintenance is for your agency.
Someone had asked that loaded question, didn't they? Right now we hadn't really put those numbers together, and I try to qualify some of those costs by who does it, like whether our maintenance guys, but we're still working on that, and that's a good question. And I'm still looking within a year to kind of really put that to number to actually broadcast.
So another question was whether the software is available, basically, for beg, borrowing, or stealing, I guess.
Oh, software, or are they looking at a GIS model?
GIS model.
Yeah, that we don't tend to submit that. We do share within the Maryland DOT modal, but there is an opportunity to at least show elements of it to help people put them in the right direction. It does cost some money, and right now it's kind of geared really centric to Maryland stormwater type requirements, but I can be available to guide people in the right direction.
Another question for Lee. is how did you bid your media filter drains? Itemized or lump sum, and then were there any savings on how you did it?
It depends on the design build or design bid build. If it's a design build project, I think we bid the whole project as lump sum contract. So sometimes it costs like couple $100 million for the entire project. If it's design bid build, I see people get bid differently. Sometimes they itemize the items, or sometimes they bid by a linear foot. And if they bid by a linear foot, they have to have a sort of detail what would be included in those linear foot.
Okay. I think, Lee, you were the one talking about 2 inches per hour infiltration. What was the underlying soil like?
So the underlying soil is very infiltrative. It was like, I remember it was like 20 inch per hour or more. So if it's very infiltrative, it will not treat the water to the level that we want. So we have to slow down the infiltration a little bit. So by doing that, we have to bring in a composed amendment soil and compact it a little bit to slow down the infiltration.
Okay. Scott, someone was wondering what the status was for the sort of discussions about a TS4 at the national level, and who's involved in that?
The status, I don't know if there's really a status. We've had a discussion with the EPA. As I showed you, they've responded to it. The last that I heard, that North Carolina DOT did submit their permit, their latest permit is termed a TS4. I don't know how much of that is name only or how much that applies, but it shows a step in the right direction. Most of us are delegated states, so it has a lot to do with working with your state regulator.
Okay, and then Mike, this is back to you. There's a question about essentially paint striping, and I guess the other was a little bump ups. I forget what they're called, but so how does the permeable pavement affect your ability to both paint and keep the paint on?
I don't really talk to the tech side about that, but I mean, all of those roadways are striped. They're all highway 3-lane or so kind of thing, and so just my experience from driving on the one near here that's been down 6 years, I haven't seen any issue at all. And and TxDOT's using it on Interstate 35, and some of the sites that Caltrans monitored were on I-5, and Bill Hunt sites were on an interstate. So it seems to be not an issue, from what I've seen.
Okay. And then there's a question about you made a comment about the increased de-icing applications, and the commenter is saying that the Mass DOT uses PFC quite a bit, and the anecdotal evidence suggests that OFC does require a bit more de-icer. So is there more research needed on that?
They're saying that it does take more de-icer?
Yeah, it does require quite a bit more de-icer.
Yeah. Well, the challenge, of course, is that you shouldn't be sanding it, because obviously sanding will fill up the pores in a heartbeat, and then you'll be not functional. So, and the trick is when you apply a salt, whatever chloride it is, it just doesn't stay on the road as well. It tends to drain down, and so it takes more frequent application. And the other thing about PFC is it has less thermal mass because it has more air in it. It cools faster, and it will freeze faster than conventional pavement. So, we don't do salt in Austin because, first of all, it never snows here. But and mostly the stories I've gotten about increased use of de-icer have been like from Europe, and just that it definitely has to be reapplied more frequently to keep ice from forming.
There was a commenter who said, yes, this is back to the paint stuff, that said there is a bit more material needed to stripe the pavement. So it's because some of it goes into the voids. So that's just a comment. So another question was, where do the pollutants go within the pavement, and then what do you do with them?
I mean, our thinking, basically when we've looked at it over time, we see enough reduction in porosity to account for all of the observed water quality benefits. So, you know, and you're getting more accumulation of more than just stormwater stuff, because during dry periods, I mean, there's dust fall and stuff, and particles accumulate on the road and fall in there. So what we're seeing is kind of a very slow decrease in porosity over time as this stuff accumulates. What TxDOT does is when it's time to replace a pavement, they mill that layer off, and then they allow that to be recycled into conventional pavement. They don't allow it to be recycled into more PFC.
Mm-hmm. One commenter suggested that perhaps to deal with the studded tire issues, that one could apply PFC just to the shoulders and not to the main travel lanes. So I don't know, are you aware of anybody that's taken that approach, or?
No, I've never seen it in the kind of the reverse configuration.
Okay. Well, that might be one option to think about there, is put it in the area that wouldn't be as subject to
definitely
metal objects. So with that, I think I've addressed most of the questions in here. So I'll just ask the audience again if there's any other questions. Please write those in, or comments. Oh, how's it measured? Oh, have you looked at bacteria at all with PFC?
No, we haven't. It's a good idea, though.
Yeah.
And I would expect some reduction, because you get a lot of bacteria associated with particles. Bacteria don't really like to be just free floating around, so I would expect some reduction.
Yeah.
And I'm hoping somebody like North Carolina will do that. The weaknesses of Bill Hunt's study was that he didn't have any control pavements. Every one of his pavements was PFC, and I think NCDOT is starting a new study with a different investigator now to look specifically at the water quality benefits with like a control section. And since their primary water quality issue is bacteria, I would be expecting some data to be coming out of there.
Okay. And then Lee, I was just going to ask you, have you guys done bacteria monitoring on any of the sites that you've discussed, and given the propensity of TMDLs for bacteria around the country?
No, I think we only mostly measure for metals and TSS. I don't think we model bacteria, nothing that I'm aware of.
Okay. All right. So again, I'll ask if there's any other questions. Well, any panelists, do you have any questions for each other?
Yeah, Eric, this is Scott. I just wanted to ask Mike, what does he think about the silver bullet pavement of maybe not only noise, safety, and water quality, but a greenhouse gas effect due to the friction? That could be a plus as well.
Boy, that's not anything I've really looked at very hard. Could be. I just haven't given it really any thought yet.
Well, that would be so another future research item. So, well, I haven't seen any more questions come in. So I think what I'll do now is close out the webinar. So again, I want to thank Scott McGowan, Lee Nguyen, Michael Barrett, and Peter Matijat for the great presentations you did, and also the participation in the Q&A period. So in closing, I'd like to remind everybody that the webinar was recorded, and that recording will be posted on the center's website. And I think I'll have the link up here in a minute. So you can go to that link there, the environment.transportation.org, and find both the webinar and the PDF. The webinar recording will take a bit longer. The PDF will be able to get that up there sooner. So with that, I want to thank you all for joining us today, and the webinar is now concluded. Thank you.